example. So the sample mean for the field weights of 100 boxes is 12.05 ounces, and the standard deviation is S equal to 0.1. Find the 85% confidence interval for the mean field weight of the boxes. So in this case, what we have is a sample of boxes. So the sample consists of 100 elements. The mean is equal to 12.05, and the sample standard deviation is equal to 0.1. So we need to find the confidence interval for 85%. So that means that 1 minus alpha is equal to 0.85, and therefore alpha is equal to 0.15, and consequently alpha over 2 is equal to 0.075. Now, what our confidence interval is given by x plus or minus z of alpha over 2 multiplied by sigma of x bar, and sigma of x bar is equal to the standard deviation of the sample divided by the square root of n. So in our particular case, S is equal to 0.1 and n is equal to 100, so is the square root of 100, which is equal to 10. 0.1 over 10 is equal to 0.01. So x is equal to 12.05 plus or minus z of alpha 2 multiplied by 0.01. Now we need to find out the value of alpha or z of alpha over 2. For that we have to go into table, and from the table we can get this value corresponding to 0.075. So from that we can get a value of z of alpha over 2 equal to 1.44. So the final answer is 12.05 plus or minus 1.44. This is from the table, multiplied by 0.01. That is 12.05 plus or minus 0.0144. Okay, well, sometimes the confidence interval is too wide to be useful, and we would like to know what is the sample size needed to reduce the interval size and keep the confidence interval, or even improve the confidence interval. So for example, let's say that in this case we want to reduce the confidence interval from 0.0144 to 0.012, and the percentage of confidence in particular will be 0.99%. Okay, so 99% means that 1 minus alpha is equal to 0.99, or that alpha is equal to 0.01 and alpha over 2 is equal to 0.005. So with this value, again, we can go to the table and look for z of alpha over 2, for which the CDF is equal to 0.005. So it's in between these two values, so that corresponds to 2.575 or if we approximate, it will be 2.58. And the negative signs, remember that it's plus or minus 2.58, so the negative sign is being taken into account. So let me go back to the exercise. C of alpha over 2 that we obtained is 2.58. Now our interval, it will be whatever, 12.05 plus or minus 0.012. So this is our new range. So but this is equal to z of alpha over 2 multiplied by sigma of x bar. Okay, so this is equal to 0.012. And if we expand and the standard deviation of the sample mean, we have that z of alpha over 2 multiplied by s, the standard deviation of the sample, a square root of the sample size, and that's where the sample size is coming, and this is equal to 0.012. So therefore, solving for the square root of n, we have equal to z of alpha over 2 multiplied by s and divided by 0.012, or n equal to c of alpha over 2 multiplied by s divided by 0.012, everything squared. And replacing for the numerical values, we have that n is equal to 2.58 multiplied by 0.1 divided by 0.012, and squares, which corresponds to 462.25, but we take just the closest integer or the top integer to be on the safe side, so that will be n equal to 463, and that's the sample size corresponding to a confidence interval of 99% and a range of plus or minus 0.012.